Welcome to this video where I'm going to have a look at the summer solstice and explain that actually it's the shortest day as opposed to the longest day. Now when I mean length of day, I'm not talking about the daylight hours, which obviously during the summer you're going to have more daylight hours compared to the winter. I'm talking about a full 24-hour period, and during the summer solstice it's actually closest to the shortest day as opposed to the longest, which we might think might be associated with the summer solstice, and we'll have a look at why that's the case. So before we do that, we need to understand two different sorts of rotation periods. So we have the sidereal period and the synodic period, and these are different. There's different amounts of rotations there of Earth, and this is then going to correspond to why we have a slightly shorter day during the summer solstice compared to the winter solstice. So the sidereal period of Earth is one 360-degree rotation. So it's rotated all the way around, one complete rotation, and that actually is just under 24 hours. So it's actually 23 hours, 56 minutes, and just over 4 seconds. So slightly less than 24 hours to do one full 360-degree rotation of the planet. And if we were to look at the stars at night, we would expect those stars to be in exactly the same position because the Earth's rotated all the way around, and they should be in the same position in the sky after it's done a 360-degree rotation. So that's the sidereal period of Earth. Now the synodic period varies throughout the year due to the orbit of the Earth around the Sun, but the mean length over the year is about 24 hours. So it's slightly longer, and it's a rotation that's slightly more than 360 degrees. So it goes all the way around and then a little bit more, and depending on where it is on its orbit, it goes more or less than that, and it does vary a little bit. So this is slightly more than a 360-degree rotation. So these two periods are quite important to understand. Now, why is the synodic period longer than the sidereal period? Well, what we have to remember is that the Earth is going around the Sun. And as it goes around, in order for the Sun to be in the same location in the sky each day, so if we were to look at the Sun and it's directly over us, the time period to get to the next day, which is in exactly the same position, is going to have to be slightly longer than one full rotation because the Earth is moved on its orbit and it has to rotate a little bit further in order to get the Sun in the same location. So this time around, we're not looking at the background stars, we're looking at the Sun. And that's why this is slightly longer, because it's moved around the Sun and it requires a slightly longer or more rotation in order to get that in the same location. And the next thing to bear in mind is that Earth's orbit is elliptical. Now this is quite exaggerated, but the furthest location from the Sun on its orbit is the aphelion, and the closest is the perihelion. And at those locations, your orbital velocity actually changes. So at the aphelion, the Earth's velocity is slowest. So on its orbit, it's moving at its slowest point when it's at the furthest away. And when it gets closest, the perihelion, its velocity is fastest, and this is because the gravitational forces between the two is greater, so the Earth speeds up so it doesn't fall into the Sun, basically. That comes from Kepler's laws as well. So it's important to note this velocity difference on the elliptical orbit as well. Now, the summer solstice occurs closest to when it's furthest away from the Sun. So it occurs around the aphelion of the Earth's orbit, in comparison to the winter solstice, which occurs when it's closest. So that means that the Earth is travelling around about at its slowest on its orbit during the summer solstice. Now, what that means is that because it's travelled slightly less, so the Sun has moved less in the sky from day to day, the Earth doesn't need to rotate quite as much, but it rotates less, and you get the Sun in the same sky. So because it's rotated less, it's less time. So if we were to look in the sky, we note the position of the Sun. As the Earth rotates, in order for you to get it at the same location, it's rotated less. It's also taken less time, because if we assume the Earth's rotation is nearly constant, then if it rotates less, it will take less time. So during the summer solstice, the Earth has moved not quite as far on its orbit compared to when it's at the winter solstice. And that would actually be the longer 24-hour period, because actually it's travelling faster and it requires a longer rotation in order for you to get the Sun in the same location. So thank you for watching, and if you enjoy, then check out some of the other videos.